All right, so far with systems of equations, we have only talked about solving by substitution. And when we've solved by substitution, we've either had both equations in slope-intercept form, or at least one equation in slope-intercept form. Now looking at elimination, we are going to have equations that are both in standard form. So you can kind of take a look at these steps yourself. I'm not going to go through them specifically. I'm just going to go through them once we get into the examples. But when we have two equations that are in standard form, we could get one into slope-intercept form and then solve by substitution like what we've been doing. But there is a process called elimination that is less steps when they are both in standard form. So here's how this works. We are either going to add or subtract these equations together. We're going to make that decision every time. It won't be the same. What our goal is to try to get rid of one of our variables. So we need to get one of them to equal 0. So if I'm looking at example A, if I add these equations together, when I add these two, this will become 0, and that's what I'm looking for. If I were to subtract them, this would become 8, and this would become 5, and so that won't help us. I need to get rid of a variable. So that means what I'm going to do, because I said this would give me a 0, I'm going to add every term in these equations to make one equation. So 4x plus negative 4x, that's 0x. That's what I want to happen. Something should become 0. 1y plus negative 4y, negative 3y, and negative 16 plus 28 is 12. So this goes away. I have negative 3y equals 12, and then I'm just going to solve for y. I'll divide by negative 3, and get y equals negative 4. Now, once I have my y value, just like we've done in the past, we're going to pick one of our equations and plug it back in. So I'm going to go back up to this top one. We have 4x plus y is negative 4 equals negative 16. Now, in the past, we've had a slope-intercept form equation just to plug into, so it pretty much just gave us the answer right there. Now we don't have that, so we're going to actually have to solve for x. So to get x by itself, I have this negative 4. To get rid of a negative 4, I'm going to add 4. Leaves me with 4x equals negative 12. To get x by itself, I'm going to divide by 4. I'm getting x equals negative 3. So my answer, negative 3, negative 4. So really the big difference in steps is step 1. We need to decide if we're going to add or subtract the equations together. The rest, process is pretty similar. I'm actually going to erase this a little bit so I have a little bit more space for problem B. So if you need to, go ahead and pause this while you finish the work and get rid of it. All right. Looking at example B, I need to either add or subtract these equations. So if I add 3 plus negative 3, that does give me 0. Negative 3 plus 3, that gives me 0 also. So I think adding is the way to go here. So I subtract, I'm going to get 6, negative 6. So we're going to add. So 3 plus negative 3, that's 0. So 0x, negative 3 plus 3, 0y, and then negative 10 plus 0, negative 10. 0x and 0y, that's just 0. And if you remember, if I get rid of my variables and I'm left at the end with something like this that is not true, I get an answer of no solution. So both of these, when added, became 0. 0 times anything, 0, that's how I got that 0. And if I get something here that's no variables and false, I have a no solution problem. Let's try another. All right, example 2a. I need to either add or subtract these equations so that I get rid of one of my variables. If I add these, I don't think I'm going to get rid of one of them because this is going to become 14 and this is going to become negative 12. But if I subtract, I think this will work fine. 6x minus 8x, that's negative 2x. Negative 6 minus negative 6, remember, 2 consecutive negatives become a positive, so that's going to give me my 0. Remember, you have to get one of these variables to be 0 in order for this to work. And 6 minus 20, that is negative 14. So I got rid of y this time. So I have negative 2x equals negative 14. Then I solve for x. So I got to divide by negative 2, and I get x equals 7. From here, you're going to go back up and you're going to plug it into one of your equations. It does not matter which one. You should get the same answer either time. This time I have 6 times 7 minus 6y equals 6. That gives me 42 minus 6y equals 6. And my goal here, get y by itself. So I got to get rid of this 42, and this is a positive 42. I'm going to subtract 42. That's going to give me negative 6y equals negative 36. And to get y by itself, I'm going to divide both sides by negative 6. That should give me an answer, y equals 6. So that means my final answer, 7, 6. Now let's look at example B. Remember, I need to add or subtract to get one of my variables to become 0. So if I add these, negative 10 plus negative 10, it's going to be negative 20. 4 plus 4 is going to give me 8. So I'm thinking I'm probably going to have to subtract. And you have to subtract that constant term on the right too. So negative 10 minus negative 10, those become positive. It's going to give me 0x. And 4 minus 4y is going to give me 0y. And 26 minus 26, that's going to give me 0. So we had this case, something similar to this in the last slide. 0x and 0y becomes 0. So I have something at the end that has no variable, but is true. Do you remember that that is all real numbers? Or it's acceptable to say infinite solutions. Now, if you're ready, go ahead and try the next ones yourself, and then just check it for the answers. So hit pause right now, solve it, and then sort of fast forward in the video to where I give the answer so you can check your work. If not, we'll do a couple more together. So my goal here is to get one of my variables to be 0 by either adding or subtracting. So if I add, it's going to give me 2. This will give me 5 plus negative 5. That'll give me 0. So let's add. You can only do one thing. You can't do parts. So 5 plus negative 3, that's going to be 2x. 5 plus negative 5 should give me 0y. And negative 5 plus 1 is going to give me negative 4. So I got rid of my y, and 2x equals negative 4. Then to get x by itself, I'm going to divide by 2. get x equals -2. And to get y, I'm going to plug it back into one of my equations. Again, it does not matter which one. I keep going to the top, but you can go to the bottom. 5 times -2 plus 5y equals -5. So my goal here, solve for y. So I got to simplify this business here in the front. 5 times -2, that's -10. And I got to get y by itself, so I'm going to add 10. 5y equals 5. Get y by itself, I'm going to get rid of this 5 by using division. And I get y equals 1. So that means my answer, I'll put that up here on the side, so it's not too confusing. -2, 1. And if I look at number 2, I need to add or subtract to get one of my variables to be 0. So it looks like if I add, that won't help me very much because I will have 10x and I'll have -18x. So I'm thinking subtraction is the way to go here. 5 minus 5, that's 0. -9 minus -9, those two consecutive negatives become a positive, so it's going to give me 0y. -16 minus two consecutive negatives, 12, so it's -16 plus 12, that's -4. So these become 0, my variables go away. We of course know that 0 does not equal -4, so that means our answer, no solution. Remember, if you were looking at the graph version of these, you would be able to tell that they were no solution right away because these two lines are parallel. It's a little harder to see in standard forms, but they are parallel lines. We're going to do 2 more examples here. Again, if you feel like you know what you're doing, pause this video, solve it yourself, check your answer. Actually, at this point, you should do that. Make sure you know it. So I've got to get one of these to 0 by either adding or subtracting. It doesn't look like adding is going to do much for me. It's going to be 16 and -5, so I think subtraction is the way to go. So 8 minus 8, that's 0x. -4 minus -y, consecutive negatives become a positive. It's going to give me -3y. And -20 minus -17, that's going to give me -3. So I have -3y equals -3. To get y by itself, I'm going to divide by -3. Gives me y equals 1. I'll plug that back in. I'm actually going to plug in the second one. A little easier. We have 8x minus 1 equals -17. Get x by itself. Add 1. So 8x equals -16. Get x by itself. I'm going to divide by 8. And I get x equals -2. So my answer, that's terrible. -2, 1. Last problem. I need to get one of my variables to be 0. And if I add them, it looks like that will do the trick. -8 plus 8, that's 0. We add everything. -8 plus 8, that's 0x. 4 plus -4, 0y. -20 plus 20, that's 0. We've seen a problem like this before. Those variables go away. I get 0 equals 0. That's a true statement. So that means all real numbers is my answer. What that means in context of the graph these lines are actually the same. If we were to move them into slope-intercept form, you'd end up with exactly the same equation. So we have all real numbers as our answer.